Hello everyone, this is our session 15 on mathematical logic. We were doing exercise 1.5. We finished the first 3 questions. We're on question 4. The first one was done. Let us begin with the second one of question 4. Okay, so we are on exercise 1.5, question 4, the second one. Okay, so what is the second question? It says write the symbolic form of the following switching circuit, construct its switching table and then interpret it. So we were on the second one. Let us draw the circuit. It has S1, S1 dash, S2 dash and S1, S2. So it has S1, S1 dash and S2 dash. Okay, and it had S1 and S2. Okay, that is this is S1, S1 dash, S2 dash, S1 and S2, and these are all in parallel and connected with the battery and your lamp. Okay, so this is your current. Okay. Yes, so let us write its symbolic representation. So we will have S1 is equal to P, negation P, S1 dash, this is negation Q, this is P, and this is Q. Okay, so they're all in parallel, so we write as P or negation P and negation Q, or we have P and Q. Okay, all these are connected in parallel. So this is your symbolic representation. Let us begin with the truth table of the same. So we need a truth table for this. Okay. Okay, and what are the values that we require? P, negation Q, and Q. So we have P, Q, negation P, negation Q. Okay, negation P and one second. Negation P and negation Q. P and Q. Then we have P or negation P and negation Q, and then that is with or and P and Q. So we'll just write in the numbers so it will become easier for us to write the last columns. 1, 2, 3, 4, 5, and 6, 7, 8. Okay. So this will be P, Q, negation P, negation Q. Okay. Negation P and negation Q. And negation Q over here. Okay, then we have P and Q in one of the brackets, so P and Q. Okay, then the first part we'll do the ORing, so P or negation P and negation Q. So P or 5, so 1 or 5, okay, and then 1 or 5, and then it is ORed with P and Q. So 7 ORed with 6. Okay, I've just written the numbers so that it's smaller. It's a small space. I'm writing the numbers. 1 or 5, that is P or negation P and negation Q, and then this column, 7th column, ordered it with the 6th column. Okay, let us begin. 1 1 0 and 0, 1 0 1 0. Okay, so 1 0 1 0, the negation P will be 0 0 1 1 0 1 0 1. Okay, then negation P and negation Q, 3 and 4, so 0 0 0 and 1. Then P and Q, so first and second, 1 0 0 and 0, 1 or 5, so first or the fifth one, 1 or 0 1, 1 or 0 1, 0 or 0 0, 0 or 1 1. Then the last column, 7 or 6. So this column, 7th column or the 6th column, 1 or 1, 1, 1 or 0, 1, 0 or 0, 0, and 1 or 0, 1. So how will we interpret this circuit? You can see that the output, that is the last column, is 0 when P remains off, okay, and Q is on, right? So okay, so the interpretation of this input-output circuit would be that the circuit will work all of the times other than when P, that is S1 is off, okay, and S2 is on, then lamp will not glow, okay. Then lamp will not glow. This is how you will interpret the circuit. Okay, let us go to the next one of the question 4. So we are on the third one now. The circuit diagram of the third one. We have S1, S2 dash and S3 dash in parallel. So S1, S2 dash and S3 dash. All these are in parallel. Then they are in series with another parallel combination of switches, that is S1, okay, and S2, S3 in series. Yes, so this is your circuit. Let us write its symbolic form. So what will be the symbolic form over here? 3 switches are in parallel. So we have S1 is P, okay, in parallel. So or negation Q or negation R. Okay, this is your first bracket. This is in series with, so and what is it? S1. So we put a bracket S1, that is P, in parallel with 2 series switches, S2, that is Q and R. Okay, so this is your symbolic representation, P or negation Q or negation R, and P or Q and R. Okay, let us begin with the table. Okay, so we require 3 over here. We have P, Q, R. Okay, we have P, Q, and R, negation P, negation Q, and negation R. All 3 negations are there. Then we have P or negation Q, P or negation Q, that is ORed with negation R. Okay, then we have Q and R in the next bracket, P or Q and R. Okay, and then we have the entire thing ANDed. So we'll put the column numbers, that will make our work easier. Okay, 1, Okay, so we'll have this as our table. Let us begin with the columns. So we have P, Q, R, negation P, negation Q, and negation R. Okay, then we have negation Q or negation R. So I'll put the numbering and we'll use the numbers only for the representation. So negation Q or negation R will be 5 or 6. Okay, this is our seventh column. Okay, then we can say P or the bracket, so 1 or 7. Okay, we have 1 or 7. Okay, then we can write this as the eighth column. Then we have Q and R. So we'll put Q and R over here. This is our ninth column. Okay, then with the ninth column, after that we have P or Q and R. So 1 or 9. Okay, this is our 10th column. And the last one will be P or negation Q or negation R. So 8th column and the 10th column. Okay, so put this here and the 10th column. Okay. So let us begin. We have 1, 1, 1, 1, 0, 0, 0, and 0. Then 1, 1, 0, 0, 1, 1, 0, and 0, and alternately 1 or 0. Okay. Then we have negation P. So 0, 0, 0, and 0, 1, 1, 1, 1. Negation Q, 0, 0, 1, 1, 0, 0, 1, and 1. Negation R will be 0, 1, 0, 1, 0, 1, 0, and 1. Okay, now 5 or 6. So negation Q or negation R. Okay, so 5 or 6, 0 or 0, 0, 0 or 1, 1, 1 or 0, 1, 1 or 1, 1, 0 or 0, 0, 0 or 1, 1, 1 or 0, 1, 1 or 1, 1. Okay, then we have the eighth column as 1 or 7. That is the first column or with the seventh column. So 1 or 0, 1, 1 or 1, 1, 1 or 1, 1, 1 or 1, 1, 0 or 0, 0, 0 or 1, 1, 0 or 1, 1, 0 or 1, 1. Okay. Then we have the ninth one, Q and R. So that is second and third. Okay. Q and R, second and third. So 1 and 1, 1, 1 and 0, 0, 0 and 1, 0, 0 and 0, 0, 1 and 1 again 1, 1 and 0, 0, 0 and 1, 0, 0 and 0, 0. Okay. Then the 10th column is 1 or 9. That is the first column or the ninth column. So or we have to do. So 1 or 1 is 1, 1 or 0, 1, 1 or 0, 1, 1 or 0 again 1, 0 or 1, 1, 0, 0, 0, 0 or 0, 0, 0 or 0, 0. Now the last one is 8 and 10. So 8th column and the 10th column, 1 or and so 1 and 1, 1, 1 and 1, 1, 1 and 1, 1, 1 and 1, 1, 0 and 1, 0. Ending we are doing, so both have to be 1. 1 and 0, 0, 1 and 0, 0, and 1 and 0, we have 0. Okay, so we have 1, 2, 3, 4, it will remain on. So what does it mean? That when the switch 1, that is S1 is on, when S1 is on, lamp will glow. Okay, and what you'll write, irrespective of status of, 1 second, you can write Okay, so we'll write over here when S1, I'll write the interpretation again for you. It says when S1 is on, lamp will glow. Okay, you can say irrespective of status of S1 and S2 and S3. Status of S2 and S3. Okay, so only S1 has to remain on, then the circuit will work irrespective of S2 and S3. Okay, this is our third one. Okay, let us go to the next one of exercise 1.5, question 4. Okay, so question 4 had only 3 questions. Let us go to the fifth one, question 5. Okay, so question 5, exercise 1.5. What does question 5 say? Obtain the simple logical expression of the following. Draw the corresponding switching circuit. Okay, so let us take the first one. It is P or Q and negation Q. So the first one is P or Q and negation Q. Okay, so what is Q and negation Q? Complement law, right? So what does the complement law say? Q and negation Q is F. So P or F. P or F, identity law. Okay, so what is the answer for identity law? P or F is P. Right, so this is a simplified form of the statement pattern, and then the circuit will be with one single switch, lamp, and you can write S1 over here. This is your circuit. So this is the first one of question 5. Let's go to the second one. Second question is negation P and Q in one bracket. Okay, negation P and Q, or negation P and negation Q. Okay, and we have or P and negation Q. Okay, okay, so negation P and Q or negation P and negation Q. So let us look at the first two brackets. We can take negation P and common, and we'll have Q or negation Q in the bracket. Okay, and this last bracket as it is P and negation Q. Okay, then negation P as it is ANDed with Q or negation Q is true. What is this? Here we have used distributive law in the first step, and the second one is complement law. Okay, and that is the answer is true. Then we write P and negation Q. Okay, now negation P and T will be negation P only, or P and negation Q. Okay, then we'll expand this bracket. So we'll have negation P or P, okay, ANDed with negation P or negation Q. Okay, so again we'll use complement law. Negation P or P is true, ANDed with negation P or negation Q. Okay, so what is true and negation P or negation Q? There we'll use identity law, and so we will get the answer as negation P or negation Q as our final answer. Negation P or negation Q as the final answer for true and negation P or negation Q. Okay, this is the final answer. What will be the switching circuit? It is OR, so we will have two switches in parallel. Okay, which are those two switches? S1 dash and S2 dash. Okay, and then we will have the battery and the lamp connected. Okay, yes, So this is our question 2 of or the second part of question 5. We've got the simplified expression as well as the logical switching circuit. Okay. Now let us go to the third one. Yes, so the third question, what is the circuit? What is the equation that they have given us? P or negation Q, P or negation Q or negation R, okay, in one bracket, and P or Q and R in the other bracket, P or Q and R in the other bracket. Okay. So now let us simplify this. So we can write this using the De Morgan's law as P or negation of Q and R. If you remember negation of ANDing, that is negation Q and R will be negation Q or negation R, and that is why I've written it in De Morgan's law in the reverse order. Negation Q and R, okay, and sign as it is P or, and I'll put this part in the bracket so that we can see the analogy over here. You have P or a bracket, P or a bracket. So what do we have in common over here? We have P or common. We're going to use distributive law and put this P or outside. Put a bracket. We're left with negation Q and R, okay, and Q and R. Okay, so what is P or this? Now observe, let us say that I call this part as S, this part is S. Okay, so we have P or bracket negation S and S. Can we use complement law over here? Yes, so negation S and S will be F. Okay, complement law for ANDing is F. So we'll have P or F by complement law, and then by identity law, P or F is P. So what have we got as the answer? P. Okay, so the final switching circuit will be just a single switch over here with your battery and your lamp. This is the simplified expression, P and the switching circuit. Okay, this is question 5, third one. Okay, so let us go to question 5, the last one, that is the fourth one. Okay, so the question is P and Q and negation P, okay, or negation P and Q and R, okay, or there is a third bracket, what is that? P and negation Q and R. Okay, so we'll take the first bracket. Now in the first bracket, we have P and negation P. So we'll write it together, P and negation P and Q. Okay, the remaining brackets as it is, negation P and Q and R, or P and negation Q and R. Okay, now P and negation P is complement law. P and its negation is F. Okay, F and Q, or the brackets again, so negation P and Q and R, or P and negation Q and R. Okay, now F and Q is again identity law. F and Q will be F. Okay, so F or the two brackets again, negation P and Q and R, or P and negation Q and R. Okay, now again we can use identity law for F or any other bracket, or F or P, F or Q is the brackets itself, the sentence itself, the statement itself. So negation P and Q and R, okay, or P and negation Q and R. Okay, we are left with two brackets. We've eliminated one bracket. Let us solve with these two brackets now. So observe these two brackets. We have and are common in both. So we are going to take and are common. So we write it as are and. Okay. And the first bracket is negation P and Q. Negation P and Q. Okay. Or P and negation Q. Or P and negation Q. Okay. This is our bracket that is left. Now we'll do the expansion inside the bracket, or we can say the distributive law inside the bracket. So negation P and Q or P and negation Q. What do we get with expansion? Negation P or P and negation P or negation Q and Q or P and Q or negation Q. Okay, this is your expansion. So now we can use the complement law for this one and this one because they're same. Negation P or P is true and Q or negation Q is true. So we are left with R and true and negation P or negation Q. Okay, and Q or P. Okay, and the last one again will be T and T. Okay, so T in negation P or P and T in Q or negation Q. So let us use the identity law here. T and any statement is the statement itself. Okay, so we have left with R and outside. In the square bracket, we are left with this bracket and this bracket with an and sign. Negation P or negation Q. Okay. Negation P or negation Q. Okay. And Q or P. And Q or P. Okay. So we're left with these two brackets. Now what we will do is we will give R to each of the brackets inside. So R and negation P or negation Q. Okay. And R and Q or P. Okay, so R and negation P or negation Q and R and Q or P. Now we'll expand this with R. So we have R and negation P in one bracket or R and negation Q in one bracket. Okay, and again square bracket R and Q or R and P. Okay, let us open all these brackets. So we have R and negation P or R and negation Q and R and Q or R and P. Okay, now look at the first bracket R and negation P and we have R and P. So we'll take them together. So we have R and negation P. Okay. Now the sign next to R and P is OR. Okay. R and negation P is your first bracket or R and P. Okay. Or R and P. Okay. Then or R and negation Q or R and negation Q. Okay. And R and Q and R and Q. Right. Now we'll take R and common in both of them. So R and negation P or P, okay, or R and common, negation Q and Q, okay. Then we have R and what is negation P or P? It is true, okay, or R and what is negation Q and Q? It is F. Now, what is R and T? It is R, or R and F, it is F, identity law, and therefore R or F will be R. So we are left with R in the end. So the switching circuit that we'll get is R is represented by S3, so we'll put S3 over here. Okay, so this is our question 5, fourth sum. If you have any doubts in the same, let me know. I will solve it again for you. Here we come to an end with the chapter logic with all its exercises. Miscellaneous, I'm leaving it up to you. They are simple, similar type of problems. So if you have any doubts, you can go through the videos that we've done before. And if not, then if you're not able to solve it, then please write to me so that I can help you in that. In the next session, we will start with the new chapter, matrices. Of Mathematics and Statistics Part 1. Thank you very much.